away, so then I'm going to, which you haven't learned. So you could do it in your calculator. You could find the derivative. Sorry. So this is what your calculator should give you. Oops, plus, this is 2t plus 3, and then minus 3t squared. So you could actually get out your derivative from the calculator. So you'd have to use an 89 for that one though, and then you could plug in, and you could see that you're going to get a negative value. Okay? So either way is good. Alright. The graph shows the position, so here's my position, of the particle moving along a horizontal coordinate axis. And here it wants me to graph the velocity and then graph the speed. Well, velocity is going to be easier to graph, and then I can flip anything that's negative up above for my speed. So let's look at this position. Here I can see that this position from here to here, if I was kind of to look at a piecewise function, so from 0 until 2, okay, so from 0 to 2, I can see that I have this constant, y equals 4. So if I'm going to look at the derivative at that part, we know the derivative would be 0 from 0 to 2. So from 0 to 2 up here, I'm going to have that it is 0. And I'm going to leave those points open because that's not differentiable. And we're not sure what's happening at 4 yet. Okay, from from 2 until 4, I can see that I'm going to have this y equals, let's see, a negative, down 2, down 4, over 1, negative 4, down 4, over 1, yeah. So negative 4t plus some constant, and if you wanted to solve for it, you can, but I'm only worried about the slope here because that is going to end up being a negative 4. And again, that's from 2 to 4. So from 2 to 4, I am going to be down here at negative 4. And we could kind of continue that if we wanted to write out the piecewise functions, but I'm going to eliminate because that's just kind of a lot of work and just look at the slopes. So this slope right here from 4 to 6 goes up 2 over 2, so that would be a negative 1. Or positive 1, oh my gosh, DeRose. Okay, that's not there. Positive 1. And that was from 4 to 6. And then it looks like that's constant right there from 6 to 7. So from 6 to 7, I am at 0. Okay, so now for speed, all I'm going to do is take anything that was below, which is only this one right here, and flip it above. So I still have that, and this one was from 4 to 6. So I still have those, but I'm just going to take that guy where it was at negative 4, flip it above, so it will be at 4. Okay? Okay, so A says, when is the particle moving to the left? It's going to be when V of t moving to the left. So moving to the left is when V of t is negative. And here I can see that it is moving to the left. V of t is negative from 2 until 4. So when is the particle moving to the right? It's going to be when V of t is greater than 0. So that's going to be, looking up at that graph, from 4 to 6. And when is the particle standing still? Is when V of t equals 0. And I have a couple places. We can see from 0 to 2, union from 6 to 7. I like this one. When is the particle moving the fastest? is going to be when the speed is greatest. So like basically where do I have the largest speed output? So if I only looked at v of t, I think, oh, it's going to be the greatest up here at 1, and that occurs from 4 to 6. But just because, like, this is the velocity moving to the left, so here I'm moving the fastest, though, while I'm moving to the left, but it's going to happen from 2 to 4. So my speed is still the greatest there. So from 2 to 4. That's a fun one, huh? Alright, so now here is my v of t. Now I'm going to find the graph of a of t. And again, these are all straight lines for us right now. It's kind of making life easy, so I'm just going to use my slope. Down 2 over 1, so a slope of negative 2. Let's see, down 1 over 1, so a slope of negative 1 from 2 to 3. And then from 3 until 5, let's see, I go up 1, 2, 3, 4, 5 over, so 5 halves, which is about 2.5, and that was from 3 to 5. And then it's constant from 5 to 6. There's my acceleration. So when does the particle reverse direction? So it's going to be when v of t changes from positive to negative, or negative to positive. So when it's going right to left, so that's right to left, and then this would be left to right. So where does that happen? I can see it's at these zeros here. So when t is 1, okay, this one's going to require a little bit more work. We're going to have to find the equation of this line, guys. So let's see. I'm going to use point slope. Y minus, so I'm going to use this point 3, negative 3, and my slope of 5 halves. Y minus y1, so plus 3 equals our slope times x minus x1. So that would be 6 halves plus 5 halves x minus 21 halves. Okay, so I want to know where that's going to be 0. Where's that x-intercept? So at 21/5, which is 4 1/5, which looks about appropriate. Okay. Alright, when is the particle moving at a constant speed? So here I can see it's moving at a constant speed. So here velocity is changing, velocity is changing, velocity is changing. Oh, okay, there's a constant. So from 5 to 6. When is the particle moving at the greatest speed? So it's, you got to look at the positive slopes and the negative slopes. So let's see. This slope we said was 5 halves. So let's see, looking at that graph again, from our t values from 0 until 2, we said we had a slope of negative 2. Greatest speed, oops, sorry, hold on. Okay, speed, I'm sorry, I was looking at the wrong thing. The greatest speed, so if I took my velocity function, let's see, 1, 2, 3, 4, 5, 6. And I'm just going to flip it up again. to get my speed. This is my time. So I have 1, 2, and then it's 1. And then I'm going to go, this line goes back up, so at 2, I'm back at 2. And then it's going to go at 3, I am now at positive 3. And then, where am I? 3 to 4, let's see, so 4, I am back at 0. And then that gets to stay. So let's see, at 5, I'm at 2. And then it's constant. Okay, so there's my speed. So when is the speed greatest? Right there, which happened at time equals 3. And it looks like that's in seconds. So when is the particle speeding up and slowing down? So we're going to be speeding up. So speed is increasing when velocity and acceleration have the same sign. So basically, if I look at these graphs, this is where velocity is positive, this is where velocity is negative. This is where acceleration is positive, this is where acceleration is negative. So I got to see where they happen to have both positive or both negative. So both positive, let's see, 4 would occur from 4 to 5. And both negative, let's see, would go from 1 to 2, 2 to 3, and that's all. So when is speed decreasing, slowing down? So this is where V of t and A of t, have the same sign for my justification. So that's for that part. So where is speed decreasing is when they have opposite signs. Okay, so it's going to be decreasing when B of t and A of t have opposite signs. So let's see, I am positive from 0 to 1, but negative over here. So from 0 to 1. And then, let's see, I am negative, negative from 1 to 2. From 2 to 3, I am negative, negative. From 3 to 4, velocity is negative, but acceleration is positive. So from 3 to 4, alright, let's do unions instead of commas on all those. So 3 to 4, from 4 to 5, I'm positive, positive, 4 to 5. And then from 5 to 6, it's constant, so it's neither, 0. So 0 to 1 and 3 to 4. Okay, last page. A particle moves along a vertical coordinate axis so that its position is given by this function. Find the displacement during the first 6 seconds. So the displacement is just going to be s of the 6 minus s of 0. What's that change that has occurred? That's the displacement. So I'm going to find s of 6. I'm going to put that in my calculator. I could do it by hand, but really I'm going to save time right now. So 1/3